Our next example is finding the determinant of a 4 by 4 matrix. So the solution is we need to specify a row or a column in which we're going to expand. Expansion by which row or which column? So which row should I use, or which column should I use? So the trick here is that we need to select the row or column with most zeros. Let's look at the first row. First row contains only one zero. Let's look at the second row. Second row contains only one zero. Third row, two zeros. Fourth row, one zero. First column, it contains one zero. Second column, it contains no zeros. Third column, it contains three zeros. And the fourth column, it contains only one zero. So I'm going to expand using the third column. So the third column expansion, three of the entries are zeros. So let's expand using the third column. So the determinant will be A13 C13, A23 C23, A33 C33 plus A43 C43. Now the beautiful thing here is that A23 C23 will be 0, A33 C33 will be 0, A43 C43 will be 0. And why is that? Because the element A23 is 0, and the element A33 is 0, and the element A43 is 0. Multiplying any number by 0 will give me 0. So that means all of these are cancelled. So in order to find the determinant of A, it's sufficient to find A13, C13. So A13, first row, third column is 3. We're left to find C13. How do I find C13? Using the minor M13. Now, M13, 1 plus 3 is 4. And 4 is an even number. Negative 1 power 4 is 1. So C13 would be the same as M13. So simply finding C13 is the same as finding the minor M13. M13, the minor M13 will delete the first row and the third column. What's left? Negative 1, 1, 2, 0, 2, 3, 3, 4, negative 2. So now we have a 3 by 3 matrix. We find its determinant. How we will find the determinant? Using the rules that we just took. So finding the determinant, finding the 3 by 3 determinant, we need to select also a row or a column to expand using minors and cofactor. So I will select the second row because it contains a 0, and then we'll find the determinant. The determinant happens to be 13. You have to do it by yourself. Try to do it by yourself. So C13 is 13. That means the determinant of a 4 by 4 matrix is equal to A13 times C13. What's A13 is 3. What C13 is 13. 3 times 13 will be 39. So this is the determinant of a 4 by 4 matrix. This is how to find the determinant of a 4 by 4 matrix. Now, going with our lesson, triangular matrices. What do I know? What do I mean by a triangular matrices? We have upper triangular matrix and lower triangular matrix. Upper triangular matrix, that means all the elements under the diagonal are zeros. So if you look here, all the elements are zeros. This is called an upper triangular matrix. Lower triangular matrix, all the elements above the diagonal are zeros. Now to find the determinant of a triangular matrix, simply multiply all the elements of the diagonal together, and this will give me the determinant. If A is a triangular matrix of order n, then its determinant is the product of the entries on the main diagonal. That is, determinant of A is equal to A11, A22, A33, etc. Example, this is a triangular matrix. All of the elements, all of the elements under the diagonals are zero. So simply the determinant will be 2 times negative 1 times 3, which is negative 6. Also, this is a triangular matrix. 2 times negative 1 times 1 times 3. 2 times negative 2 is negative 4 times 1 is negative 4 times 3 is negative 12. And this one is also a triangular matrix. Negative 1 times 3 times 2 times 4 times negative 2 will be 48. Now, using determinants to determine if a matrix is invertible. What do I mean by invertible? Invertible means it has an inverse. Let A be an n by n square matrix. Then A is invertible if and only if the determinant is not equal to 0. Which of the matrices has an inverse? So to find whether a matrix has an inverse or not, we need to find its determinant. Use the method that you learned and find the determinant of this matrix. Also find the determinant of matrix B. The determinant of matrix A will be equal to 0, while the determinant of matrix B will be different than 0. That means A, it has no inverse. Matrix B, it has an inverse. So again, let me repeat. A is invertible if and only if the determinant is different than 0. So if the determinant is different than 0, then the matrix has an inverse. So matrix A, its determinant is 0, that means it has no inverse. Matrix B, its determinant is different than 0, that means it has an inverse. Okay, going to the last and final idea in this lesson, Cramer's rule. If a system of n-linear equations in n variables has coefficient matrix with a non-zero determinant A, then the solution of the system is given by x1 equals to the determinant of A1 over determinant of A, x2 is determinant of A2 over determinant of A, xn equals determinant of an over determinant of A. Or we can say x, y, z, w, etc., where the ith column of AI is the column of constants in the system of equations. Let's take this system of equation. A11 x1 plus A12 x2 plus A13 x3 equals to B1, which is a constant, B2 is a constant, B3 is a constant. So this is a system of equations, three equations, three unknowns. What do I do? To find x3, or let's say it's x, y, and z. Okay, in this case, x3 is z. To find x3, we take A3. What do I mean by A3? A3, we take the coefficient matrix. See, this is the coefficient matrix. A11, A12, A13, A21, A22, A23, A31, A32, A33. We take the coefficient matrix and replace the third column, which is A13, A23, A33, by the coefficient column. So we replace A13, A23, A33 by B1, B2, B3 over the coefficient matrix, which is A11, A12, A13, A21, A21, A22, A23, A31, A32, A33. We find the determinant of the first over the determinant of the second. Example, Cramer's rule for a 2 by 2 matrix. Look at this system of equations. It's two equations to unknown. We have x and y. 2x minus 3y equals to 12. Negative x plus 2y equals to 9. So first of all, step 1, extract the coefficient or find the coefficient matrix. Okay, we take 2, negative 3, negative 1, and 2. 2, negative 3, negative 1, and 2. We find the determinant. 2 times 2 is 4. Negative 3 times 3 is 3. 4 minus 3 is 1. So the determinant of the coefficient matrix, calculate the original matrix, is 1. Second step, solving for x. Replace the first, because I have x and y. So we replace the first column of the coefficient matrix with the constant matrix. What's the constant matrix? It's 12 and 9. Constant column is 12 and 9. So we replace 2 by a negative 1, we replace it by 12 and 9. And then we find the determinant. So determinant is going to be 12 times 2 is 24 minus negative 3 times 9 is 27. We add them 51. So that means x should be equals to 51 over 1. From where did we get 51? From A1. From where did we get 1? From the coefficient matrix. Now how do I find y? Part 2, solving for y. Replace the second column of the coefficient matrix with the constant matrix. The second column of the coefficient matrix. This is the second column of the coefficient matrix. We replace it by the constant matrix or constant column, which is 12 and 9. We replace it by 12 and 9. And then we find that 2 times 9, 18, minus 12 times negative 1 is negative 12. 18 minus negative 12, it's 18 plus 12, which is 30. Now, to find y, it's 30 over the determinant of the coefficient matrix. 30 over 1 is 30. Now, example of a 3 by 3 matrix. Cramer's rule for a 3 by 3. So, we use Cramer's rules to solve the system of linear equations for x. We have x, y, and z. This is a system of 3 equations, 3 unknowns. 3 equations, 3 unknowns. So now we'll use Cramer's rule to solve such an equation. Okay, so first of all, we need to find the coefficient matrix. What's the coefficient matrix? It's going to be negative 1, 2, and negative 3, 2, 0, and 1, 3, negative 4, and 4. What about the constant matrix? It's 1, 0, 2, or the constant column is 1, 0, 2. So this is the coefficient matrix, negative 1, 2, negative 3, 2, 0, 1, 3, negative 4, and 4. We find the determinant. We find its determinant, 10. It will be 10. Now to find x, we replace the coefficient matrix. We replace the first column, the column for x, by the constant column. So I replace this column, negative 1, 2, and 3, by 1, 0, and 2, and find the determinant. And then we divide it, the result, we divide it by the determinant of the coefficient matrix. And it will be 8 over 10, which is 4 over 5. To find y, we take the coefficient matrix, we replace the y column, which is 2, 0, and negative 4, we replace it by the constant column 1, 0, and 2, find the determinant, and then we divide it by 10. Also, to find z, we take the coefficient matrix, we go to the last column or the z column, which is negative 3, 1, and 4, we replace it by the constant column, which is 1, 0, and 2. So instead of this column, negative 3, 1, and 4, we'll replace it by 1, 0, and 2. So we'll have a new matrix. We find the determinant. Okay, after finding the determinant, to find z, the result divided by the determinant of the coefficient matrix, which is 10. The result will be negative 8 over 5. And this is the end of our lesson. Please be safe and take good care of yourself. Thank you so much.